Okay, welcome back. So this video is going to be about evaluating the quality of the test, and we're going to look at certain parameters. So let's get started. Again, we're going to pull up our little chart here. If we look here, we're going to be dealing with this very first panel, and the first panel is what we're going to use in order to determine the quality of the test. And let's take a look. If you'll notice on this panel, I've put a way to score the test, and so that's what we're going to do first. So let's start with the first part of it. The very first one is the length of the test. Korr recommends between 8 and 12 minutes because there is a certain amount of data that needs to be collected so that it can make it accurate. And so this test goes all the way until we see the black line, which is a marker of the end of the test. We see the test is 11 minutes. So the very first goal here is to get a test that's at least 10 minutes, and that's what we aim for. So on the left side, I scored this test. I gave it all 10 points because the length is good. The second measurement or parameter we want to judge a test on has to do with the slope of the heart rate in the red. And so that slope is really important, and it needs to be a continual linear line up to the end of the test. It needs to have that gradual slope that goes up and hopefully reaches somewhere near the predicted max heart rate. So when we look at this test, we see a really nice kind of a nice gradual slope on it. So in this test, I gave it 5 out of 5. So now we got a 15-point test out of 20 points. And so the issue of this gradient heart line is so important, and let me show you some examples of what will throw the test off and make the data bad. We could see that this test here, there's this really rapid rise, which is way too rapid. We don't know if this is the tester or it's actually the patient responding to some type of workout. But we have here his heart rate reaching around 105, and then we have a plateau, actually a downgrade. Then we have a start of a climb, then we have a really rapid rise, obviously you can see it, and then we have another plateau. That type of heart rate throws all of the respiratory dynamics off. We really can't trust this test. Not that it can't be useful, it's just this is not something we want to base any medical decisions off. We would want to retest this individual. Here's another one. Now that is very wild, right? How do you really do that? I don't know how that happened. I really don't. The test is obviously very short. It's 4.5 minutes, so we would probably only give it 4 points out of 10. Not that the technician has control of that. Obviously, there are times the patient has disabilities or health issues that interfere, but we just see this extremely unstable heart rate that just makes the test really poor. And all the data, is suspect after that. We do see this plateau here, but again, I want you to look at the heart rate. So we took the same person and we put him on a protocol to do the next test. And so the next one you're going to look at is actually us retesting her. And there you go. Much better line. You can see how it's much more gradual, reaches up to a higher point. And so this is what we're looking for. The test got much closer to the length of what we wanted, so it's good. I'd give it 10 out of 10 for the length, and we could also give it 5 out of 5 for the gradient heart rate. So it was really good. It was a good test, and we see that somewhere she plateaued here around 17, so it says 17.8 over here was her V02 max. If we back up, we'll see, oops, let me go back to her. We'll see on this one a 14.9. So it really did affect her score, and so that is obviously what we want to look at. Let's see if I have another one. All right, here's another issue with looking at the heart rate line. Is this particular test, the workload came on rather fast because the patient starts off at 75 beats, and in 5 minutes he's up to 155, 160 beats. And if this is kind of near his predicted max, which it looks like his predicted max is somewhere here, maybe not, but if he reaches that very early on, he has to plateau, and that plateau right there in the heart rate will also reflect a plateau in the VO2. Because remember the Fick equation, that VO2 is dependent upon cardiac output. And where there's a limit or a plateau in cardiac output, there usually will be a limit to the VO2. So that type of heart rate that is accelerated like that in a test will force a plateau and will also throw off the VO2 score. The patient did very good, but probably would have had a better score. So this particular gradient should come up much slower, much more angled, more consistent through the test. We have a protocol for that, but it doesn't look like it was used here. Okay, and then we have another one that's similar like that. We have a patient whose heart rate was again accelerated very fast. Within 6 minutes, they're reaching almost 160 beats. So at this point, we can also tell that they exhausted in the test must have ended here, because we just see the heart rate drop after that. And of course, that affects all of the VO2 and CO2 measurements that we would have. So let's see, got another one. This is another test. Started off slow. It became very steep from minute 2 to minute 5. So within 3 minutes, we went from 115 beats to 180 beats. Just way too steep. The shortness in time, since it's not a 10-minute test, the data gets really short. So now the data maybe isn't as accurate as it should be when we get it. So this type of test right here, if we were to score this test, how many points out of 5? We'd probably only give it 1 or 2. It's not a good test. The previous one to that, again, 1 or 2 points. That's not what we're looking for. This one, maybe 2 points, but it still jeopardizes the information. This one, we could give it all 5 points, a nice gradient line. That one, we should just throw the test away. This one, the test is compromised. We might give it 1 point. This is what we're looking for right there. So the next measurement on this is the RER measurement, and we'll look at that at the next panel. We'll stop right here.